delete by looking into any of the variable missing. All right. So this is the most simplest method, right? Where, for example, like if you look at the missing values in the table on your left, Miss Richa, all right, where we have missing values for the gender, as well as Miss Rashmi, right, where the missing value for the gender. So which means that we just cross or we just delete the row, right, for the missing values. Okay. But for the another one, for we call it a pairwise deletion, right? So for pairwise deletion, we just perform the analysis with all the cases where the variables of interest are present, right? So the good thing about this is that it will keep as many cases available for analysis. But the disadvantage of this pairwise deletion is that it uses different sample size of different variables, right? So if you want to have easiest strategy for the deletion, normally we use the listwise deletion. But again, you will have to check the numbers or the amount of your data, because for the listwise deletion, you will delete any of the variable which has the missing values, right? So which means that you will reduce the sample of size in a very large amount of it. Okay, so that will be for the deletion of the missing values, right? So okay. So how about the imputation, right? So for imputation, as we know that for imputation, we try to fill up the missing values with some reasonable data, right? And how are we going to do that? So normally, because our objective here is to make sure that we fill up the missing values with the most reasonable data. All right. So we try to identify the valid values of the data in order to try to estimate the missing values. Right. So one of the way is we can use the mean, the mode, the median. All right, to compute the values. All right, so these are the most easiest method. All right, in order to calculate to replace the missing values. All right, so we can use the mean, the mode, the median, or you can also use some kind of models or algorithm. For example, like k nearest neighbor, right? So the simplest model would be the KNN or k nearest neighbor, all right? Where in this case, as we know that for the k nearest neighbor, you look into the neighbors, right? You predict based on you can predict the attributes based on the occurrences of the neighbor. All right. So in this case, if you are using the KNN, they will try to predict or the attribute are imputed using the given number of attributes that are most similar to the attribute whose values are missing. All right. So this similarity of the two values, normally it be determined by the distance function. So for k nearest neighbor, they use some kind of distance between the attributes and the neighbors. All right. So that is if you want to use some kind of models for the imputation to replace the missing values. All right. So these are the strategies that can be used either for the deletion, all right? For the deletion, how you want to delete, all right? Or for the imputation, how you want to replace the missing values, okay? All right. And the last one would be on the data pre-processing, all right? So again, data pre-processing is a very important step, very important stage. All right. I do not want to call it a step because it's just not a very simple step. All right. But it's a stage where comprise a few steps. All right. In order to make your data ready for the analysis. So in data pre-processing, sometimes we have to do cleaning, we have to do the transforming, we have to do the normalizing the data, integrating it into a piece of the peaceful information. All right. So for data preprocessing, it's actually a process of where we want to transform the raw data into a clean and also usable format. All right. This is very important. For example, if you are developing NLP application, all right, one of the stage is to cater on only on the data preprocessing, all right, and also recognized as data preparation because it's actually we are preparing a data for the training for the models and so on, or data cleaning because sometimes we will have to clean up the data, all right, and so on, which encompasses the practice of identifying and then you rectify the erroneous of the misleading records within a data set. Okay. And why pre-processing in machine learning is very important? The first one is because we want to improve the project accuracy. There are few studies have been done, all right, which the effect of pre-processing in any of the applications, all right, even in NLP and so on, because even in NLP, we are still using machine learning as the models, all right, and from based on the studies, in fact, we also had done study on this, all right, with previously I did a study on this with my student, all right, master student, to see the impact or the effect of this pre-processing towards the performance or the accuracy of the project. So based on the study, we can shows that pre-processing has so much impact on the accuracy of the project. All right. So which means that this is a very critical process. All right. Before you move on into the model and so on, this is something that you will have to focus on, or you will have to take into a serious matter. All right, because it has a impact to the accuracy of the model later on. All right. Secondly is to enhance the efficacy of the machine learning models. All right. Thirdly is to eliminate duplications, eliminate all the noisy and so on. All right. And fourth is the early detection and filtering of data issues. So once you do a pre-processing, you will see so many data issues. All right. Because in order to do the pre-processing, you will have to understand about the data. All right. the types of data, understand the nature of the data, right? So from that, you can see what is actually the issues on the data, all right? Say example that, like in my case, I'm doing a text normalization, all right? So, so normally the data that we collected are from social media. So we scrape the data from social media, all right? So once we have collected the data, right? So now we are ready for the pre-processing. But in order to do the processing, we are not sure at that point, we are not sure of what are the processes involved in the pre-processing. All right. Do we need to do the stemming? Do we need to do the stop words removal? Do we need to do the noise removal and so on? So based on the data which has been collected, you will have to review the data and then you will have to come up with what are the issues. Of course, the pre-processing also uh, must be based on the what types of applications that you want to do. All right, because sometimes not all applications may require you to do all the pre-processing steps. All right, so you will have to address, you will have to come up with what are the steps of the pre-processing based on the data issues, based on the applications, based on the types of data. All right. Okay. These are some of the stages of the data pre-processing. All right. So we have data transformation. Some of the data perhaps needs to be transformed. All right. We have data reduction. All right. We also have data cleaning. Okay. And also data integration. Okay. So here, for the first one, for the data cleaning, normally is to handle missing data. All right. So as what we did previously. All right. But what is something that is different here is that on the handling the noise or the noisy data. All right. So what is a noisy data? Who knows about noisy data? Anyone would like to explain about the noisy data? What is a noisy data? Do you think the data can make noise? What does it mean by noisy data? Yes, Michael? I saw that you're raising your hand, isn't it? Michael, isn't it?
Yes,
Okay.
Michael. Okay, I would like to answer your question.
Yeah, please.
Noisy data. For me, noisy data is a data set that contains meaningless data, or you can call it is unpatterned data, or a data that can left without any pattern from the general pattern in the data set itself. So it kind of biased. So it's a biased data rather than just normal data against the other.
Okay,
Thank you.
all right. Thank you, Michael. Okay, say that I have two types of data, right? I collected two types of data, right? One is from the newspaper, right? So I collected data from newspaper. That is one set of data. Another set of data I collected from social media. Say that from the social media tweets, right? So I have a lot of tweets here, and I have one set of tweets, and one set of articles from newspapers. All right. So with these two sets of data, all right. So which set of data do you think have higher percentage of the noisy data? Which one? A is the newspaper, B is from tweets, right? So which set do you think that have higher percentage of noisy data?
I think tweet is more unstructured and can be possibly more noisy than newspaper.
Okay. Is that Michael?
Yes, that's
Oh,
me.
okay, sorry. Okay. All right, thank you. Okay. Yes, correct. So if you compare these two, if you want to see what is actually the definition of the noisy data, all right? You just look into these two set of data, all right? Look at the types of data from the newspaper, the articles, right? And then look at the articles or the set of data from the Twitter, all right? So you can see the comparison of these two, like what Michael mentioned just now, as we know that for tweets, they are so unstructured. You can use whatever you want. You can so-called use your own language. You use a short form, you use symbols and so on, isn't it? All right. But for the article from the newspaper, they are more, even though they are unstructured as well, all right, because it's like open text and so on, but they are more proper with a proper grammars and so on. All right. So noisy text normally occurred when we have data from social media, right? Previously, when we use data from more formal text, formal kind of text. For example, like newspaper. So normally last time we use newspaper, right? Articles from newspaper, and then the one that we started to have a social media types of data set, it was when we had blogs, all right? I'm not sure whether your time you know about blogs or not, all right? Because that was not during the Gen Z, that was during Gen X or something like that, all right? So there was time where they started, or they so-called like social media, but it's more on publishing about your activities, about your journals in the webs, all right? So we call it blogs, right? So people can read the blogs and so on, and sometimes can give comments on that and so on. So, but if you look at the blogs, the way how they write the blogs is more proper compared to nowadays with the social media. And then after the blogs, they came out with Facebook, all right? So we can see that from blogs to Facebook. Of course, Facebook is different from blogs, shorter version, and then it's some kind of communications between your acquaintance, all right? Between your friends, those that who knows, right? Because you have to invite friends, right? So this is something like, but because of the limitations of the number of words to be used and so on. So from the Facebook, you can see that people tend to write in a more simple way. All right. Sometimes you disregard all the grammars, all the spelling errors and spelling mistakes, as long as you can understand. All right. So that is why from time to time you can see that different platforms they have different types of, or the percentage of the noisy text will be different, right? I also had opportunity to have a study on WeChat. Have you used WeChat before? Anyone have used WeChat before? It's an apps that is being used in China, right? Because they can't use WhatsApp, so they have a WeChat. All right. There was time when when they introduced WeChat. There was time where WeChat came in Malaysia, and there was time where we have quite a number of users for WeChat. All right. But when I did some study on that, because I was doing a study on all the social media platform, the data, because we are doing pre-processing, we are doing text normalization. So the challenges of the normalization depends on the platform, all right? So one of the platform that we tried to study on is the WeChat, all right? So we did a comparison between WeChat and also WhatsApp, all right, or Twitter. So it turns that the data that we we collected from WeChat has the highest percentage of noisy text. All right. Why? First, because the users for WeChat, they are among all the youngsters. All right, it's very common to the youngsters, but not so much to the mature adults. All right, so when these youngsters, they communicate each other using the WeChat, the language, the pattern of the language that they use is very difficult, very very simplified. All right, you can see that a lot of symbols, they use a lot of symbols, a lot of simplification, all right, which means that all the words that they use, they will try to make it short form, all right? And the short form is not a standard short form. It's a personalized short form, all right? For example, if I say that the word in Malay, saya, I, right? In Malay, saya, right? The standard short form normally we use is SY, all right? But for these youngsters, they prefer to have their own preference, all right? Preference for their own short form. They don't bother about the standard short form or whatsoever. So sometimes A would use SY, but the other user B, they will use SYA, but referring to saya as well. So sometimes when we want to analyze, all right, when we want to analyze this text, all right, you will have to consider about all these issues, all right? This is how we handle the noisy data or noisy text, all right? So that is why noisy text is very important to handle, especially when it comes, the data is related to social media, all right? But if your data is more or less is on the article from the newspaper, then maybe the noisy data, noisy text will be not so much, all right? But if you, but mostly nowadays, most of the time we use social media data, all right? So handling noisy text is very important, all right? And of course, handling inconsistent data as well. So all this has to be scrutinized, has to be addressed, okay? And then we also have data integration, right? Where sometimes we have to combine data from various sources to create a unified view. For example, if you are using social media, some of the data are coming from Twitter. Some of the data are coming from maybe for communication. Some of the data coming from WhatsApp, or some from the Telegram or WeChat and so on. So in order to make sure that it is standardized, unified, right? So you need to do the data integration to combine data from these various sources, right? And this process is very important in order to provide a comprehensive data set for the analysis. Why do we need to get data from various sources? Because sometimes from one particular source or platform, it is not sufficient, all right? So that is why sometimes you will have to get from other sources as well, all right? Then you will also do a data transformation, all right? Where for data transformation, it is actually a process of converting your data into a suitable format of analysis, all right? So in this case, there are a few techniques of the transformation, which include first, smoothing, all right? Where you will have to remove all the noise from the data, all right? Sometimes this smoothing or removing all the noise, we also call it like, it depends on what types of noise, all right? Sometimes we consider all the symbols, all the irrelevant data, or like Michael mentioned just now, which is not which doesn't give any meaning or not relevant to the data. So we consider that as a noise, which can be removed from the data. All right. Sometimes according to the study, it's not just simply removing the noise, but sometimes if you remove the noise, it will also give impact to the accuracy of the performance as well. All right. The next one is generalization, all right, where sometimes we need to convert the data to a higher level of abstraction. And normalization, right? You scale the data to a standard range, right? So this one depends on the normalization. It depends on what type of data that you use. For example, like in my case, I did normalization for the text, right? Whereby I normalize all the text where I transform the unstructured or the unknown data or unknown text into a standard form or the standard word, right? So for example, like in social media, there are a lot of words that cannot be found in the vocabulary, right? Or we call it as out of vocabulary, OOV, all right? So which means that if you look into a vocabulary or you look into any of the dictionary, you won't find the word, all right? So this is what we call as OOV, right? So from here, you want to transform this OOV into a standard form so that the machine can understand well about the text, right? So this is called normalization, okay? And also attribute construction, where we create new attributes that can help to improve the model, right? And the last one is aggregation, where sometimes we need to combine data to summarize the information, okay? Data reduction, right? So for data reduction is actually a technique where it reduces the volume of data in order to improve the efficiency and also the performance of data. Sometimes we need to reduce the data, right? In order to make sure that we can increase the performance or also efficiency, all right? The processing time and so on. So what are the things that can be reduced? First, dimensionality reduction, where we can reduce the number of attributes in the data set, right? So if you feel that any of the attributes are actually unnecessary, all right? It's just that because the data set has those attributes, but it's actually unnecessary and it is not computed into the model, right? Then we can reduce the number of those attributes. Apart from that, we also have numerosity reduction, where we can reduce the volume of the data through methods like we can use clustering or sampling, all right? So normally, like clustering and sampling, these are the two methods used in machine learning, where if you feel that the volumes are very high, all right, so perhaps you can reduce those volume, right? Data cube aggregation, where in this case you aggregate the data in a multi-dimensional space. And lastly, data compression, which is by using some kind of algorithms to compress the data. All right. So one of the example of the so-called the data compression is that, for example, if you are doing on the application, for example, like information retrieval, all right? You want to retrieve documents. So based on the query, so what we do is sometimes when you do the pre-processing, if you don't do so-called like data compression or specifically like stemming, all right, stemmer, by using stemmer, and also where when you use stemming or stemmer, you are reducing the number of words to be processed and so on, because for stemming, they are just looking into the root word, all right? So all the words will be reduced to the root word based on the algorithms, for stemming algorithms that they use. So it's easier for them, or it's faster for them to process the text, all right, rather than every single word has to be processed, all right? So that is an example of data compression, okay? All right. So there are a few, so many applications with data preprocessing. In fact, I can say that almost all applications need to do preprocessing, but the level of preprocessing depends on the types of data, the how severe the data is. All right. Like for example, just now, if I said that for data that taken from articles from the newspaper where it is being structured and also has a very nice grammar, very minimum typo error and grammatical error. So perhaps the level of pre-processing is very minimum. But if you are doing on the data which has so much noise, all right? For example, like videos. Videos also have so much noise, right? Or image, right? Taken from you only have for example, like the image from the CCTV, all right? So you want to do the analysis from the image, but of course there are so many noise from there, all right? So whatever applications, you have to start with pre-processing, but only the difference is that the levels of pre-processing that you will have to do, whether some of the pre-processing, some of the application needs a very to the maximum of pre-processing, but some of the applications only needs a few types of pre-processing. So some example of applications like in the healthcare, where they will have to prepare the clean data for analysis in order to identify the trends and patterns in patient data. Of course, in the healthcare, it is very, very important to do the pre-processing and to make sure that pre-processing is being done correctly, because you are dealing with the data, patient's data. Say that you would like to have a recommendation system for the healthcare. all right? If your pre-processing is not correct, so perhaps you may it will result into wrong diagnosis, right? And wrong recommendation, right? So that is why it is very, very important in healthcare to prepare to have a very clean data for analysis. Another thing is finance, all right? Banking, finance, where you will have to get a very clean data in order for you to improve the accuracy of your financial forecasting models. All right, of course, sometimes if you want to do the stock markets and also to forecast the financial and so on. So it's very important to get the correct and also the clean data. All right, and from that it will we can minimize the threats from various frauds and risks, right? And also personalization, right? So nowadays there are a lot of apps offers personalization, all right? Even the even the all the social medias, right? For example, like Facebook, all right, where they normally it will pour up advertisement which related to our interest and so on, all right? Netflix. So these are all the personalization where they try to personify the products and services according to our preference. And this can be done through the pre-processing as well. All right. So these are some examples of applications which have a huge impact on the data pre-processing. Okay. So as a whole conclusion that what we can say is that data pre-processing is very essential phase in machine learning workflow, right? So even the workflow that I've shown you just now, the process in machine learning, one of the phase that is very important is pre-processing, all right? Regardless whether your data is for images, videos, text, or whatever, still you need to perform the data pre-processing, but the levels of pre-processing, it depends on how critical it is, all right, for that kind of application, and depends on the type, on the data itself, all right? And it ensures data cleanliness, consistency, and readiness for the modeling, ultimately enhancing the accuracy and reliability of the predictions. So you just imagine that without the pre-processing, all right, you collect data, right, and you straight away use the data to train your models and so on, right? I'm sure that if you do a comparison, all right, if you have time, I'm not sure, maybe for your project or later on, maybe you can have like a comparison to see the impact of this pre-processing towards your performance or the accuracy of your weather predictions or classification or whatsoever. All right. So between whether you perform pre-processing and not doing any pre-processing. So what's the difference, or is there any different in terms of the performance and so on? So from that, maybe you can see, or you can see how important it is, the pre-processing in any of the machine learning process or workflow, right? And dedicating time to pre-processing can greatly improve the performance of your machine learning models. I can say that pre-processing will take much of your time when you want to do a research or when you want to do a project, right? Pre-processing would be one of the tedious or one of the longest time, because especially when you are dealing with data that is so much noise, right? Very unstructured, so much noise, and without any labels, all right? So you will have to do one by one, right? All the pre-processing steps in order to prepare to provide a good data set for the models to be trained and so on. All right. Otherwise, unless you are willing to because it's worth it. All right. Even though you spend a lot of time for the pre-processing, but it's really worth it because it will give an impact to your accuracy of the performance and so on. All right. So don't feel that doing pre-processing is wasting your time, right? Because it's not wasting your time, because it's a critical stage where it will affect your performance of the model later on. All right. If you don't believe it, try and do a experiment where with and without the pre-processing, and look at the results of your analysis. Okay, so from that you can see how important it is, the pre-processing, right? And for the pre-processing, it depends on sometimes depends on the nature or the types of the applications as well. Like in natural language processing, all right? So pre-processing has quite a number of steps, all right? Again, depends on the application that we are developing. So one of it is like just now, like stop words removal. So why do we want to remove the stop words? Stop words, because stop words are words that are common, all right? Very common words. For example, is, and the, all right? So these are all the common words, which we feel that it can be reduced. So this is one of the example of data compression, right? We try to reduce the data by removing those which is does not give values to the training, to the model later on. When you train the model, it won't give values to that, right? Because stop words doesn't give any meaning. It's just like it's just to make sure that your grammars are correct and so on. So that can be removed. So these are the things that you will have to decide when you want to do you do want to develop an application, right? Like in my case, I'm from NLP. So most of the time in NLP, in the pre-processing, we do stop words removal, we do tokenization, we do stammer or lemmatizer, right? Lemmatization, right? And then we do all the symbols removal, punctuation removal, all this noisy, all right? And so on. All right, so these are some of the steps or the processes involved in the pre-processing for text, right? But for images, perhaps they have other different, a little bit different from text, okay? But it's still under the pre-processing, where you still have to make sure that you prepare the data for the training of the models and so on. Okay. So with that, I conclude the topic. All right. So maybe I can open for 5 minutes Q&A because I'm rushing for another meeting after this.
Yes, thank you very much, Dr. Nisma. I thought we will finish before because you have a meeting.
Yeah, but it's okay. I can give another 5 minutes.
Okay. Okay, guys. Is there a question to Dr. Nurisma? regarding processing, data labeling, and augmentation. Actually, I have a question. Is that okay?
Okay, all right.
Uh, I think one of my students, like, when they labeling, they already like make sure the labeling itself, the process itself is correct.
Mhm.
But after like modeling and evaluation, like there are data that was classified wrong. But after we check it, the labeling itself is like, I think because the data itself is in text, but it's not like not based of context, I think. So I mean, is it okay like we change it, the data after we labeling, or what do you think about that?
Okay. So you mean the labeling, you do the students, they did the annotations, right?
Yeah.
So okay. So when they did the annotations, how did they do the annotations? Is there any kind of like a guideline where they will have to do the annotations, or they just how is it? I mean, because sometimes to do the annotations, we can't just simply assign to anyone. I mean,
Yes.
we need to make sure that they are the one who are, for example, like in my case, we are doing NLP. So when you do the annotations, it is on the language, all right? So we must make sure that the annotator, either they are the native speaker of that kind of language, all right? Or are they if they are not the native speaker, perhaps they are those final year students who are doing on that language and so on. So that is only the first layer of doing the labeling, but after that it has to be verified or validated by the expert, which means that normally we will appoint one expert from, for example, a professor, a teacher or professor who is a linguist, all right, to check the annotation or the label that has been done by the student, right? So from there, sometimes they found some conflicts. So that is where they will try to rectify some issues which has been done by the students previously. So it has to be two layers of validation instead of just yes. That is what we did because previously I was we were hired by one of the industry to annotate because they are developing a sentiment analysis and they have huge data with 3 types of languages: Malay, English, and Mandarin. So each data set comprise about 100K sentences. So we have to, our side, we will have to come out, first we need to come up with a guideline. How are we going to annotate the data set, right? So we divide into 3 types of data set, and we found, we try to find a native speaker for each of these data set, right? And then from that, we also has to validate whatever the annotated by these annotators with expert, the more expert than this. So they are doing the checking for all this annotation so that we try to minimize the errors when it comes to when we it comes to the training of the models, because like in this case, when once you have trained the models, normally it's I'm not saying that it is not it's wrong to correct the data set, but that will create some kind of bias as well, because you have trained the model with the data set, and suddenly you are not happy with that the results of this data set, and you go back to the data set and you try to edit or do some amendments on the data set. So this will create bias actually to the models, all right? And if you keep on doing this, I mean, like something that is not it's not the right process lah, I can say, right? Okay.
Okay, so like there is, I read in the paper, like we have to calculate agreement score, like for
Yes,
Hands Kappa
yes,
or Place Kappa is
yeah,
mandatory, right?
yes.
Oh,
That's why I said, if you when we do the annotation, make sure that you have the guideline, and then the correlation between you have to calculate the correlation between the annotators and the validators, so that when people question about your labeled data, so we can explain clearly explain about the process, because normally this is the common process, a standard process that has been used by others as well.
mm. Okay, thank you very much, Dr. Rosula. I think because the time is limited, if
Yeah,
the
I'm so
other
sorry.
it's okay, no problem. If the other have question, I will
Yeah,
answer.
maybe Dr. Mar can compile the questions, and then email or WhatsApp to me, and then maybe I can just answer through the email or text. Okay.
Okay.
All right.
Okay, thank you very much, Dr. Rosula. So we will close the class. Thank you very much. Thank you very much, Dr.
You're
Rosula.
welcome.